Welcome to this channel. In this video we are going to solve a question on current or questions on current electricity. Our main focus will be how to find the resistance in the circuit when the resistors are connected in parallel, how to find the resistance when the resistors are connected in series, advantages of connecting the resistors such as the bulb in parallel, that is in the household. We are also going to look at how to find voltage giving resistance and current, and that is applying Ohm's law equation. Okay, we are also going to look at how to calculate energy in this case. All this we are going to do it using the ECZ past paper questions from 2016 to 2019. So here is the first question in this video. The question reads, figure 2 shows a 6.0 volts a power supply connected to two resistors which are in parallel. Figure 2 shows a 2.6 volts power supply connected to two resistors which are in parallel. Calculate the effective resistance. Calculate the effective resistance of two resistors. That is the first question we are finding. Now, there are two things that you need to note here. We said we are going to look at the situation where we have resistors that are in parallel and where we have resistors that are in series. So in this case, in this question, we have two resistors, that is 4 ohms and 12 ohms. And these, if you look at them, they are connected in parallel. So how do we calculate the effective resistor? So effective resistor in this case, it just means find the total resistance. So if you have two resistors that are in parallel, this is the formula that you apply. Okay, total resistance is equals to resistor 1 multiplied by resistor 2 divide resistor 1 plus resistor 2. Okay, so making this one resistor 1 and this one resistor 2. So in this case, you are going to have resistor 1 being 4 multiply resistor 2 being 12 divide 4 plus 12. So if you multiply 12 times 4 to give you 48, divide 12 plus 4, which is just 16, and if you divide, you are going to find total resistor as 3 ohms. So this is the total resistor in the first case. The second question is that calculate the value of current in 4 ohms resistor. Calculate the value of current in 4 ohms resistor. Now, another thing that you need to know is that current in parallel, it is shared. Okay, so current in parallel is shared. So we have this 4 ohms and this 12 ohms. So the current that is passing through this circuit, it is shared. When it reaches the junction here, it is shared between the 4 ohms and the 12 ohms. And you should also take note that the larger the resistor, the lower the current that is in parallel. Okay, so this 4 ohms has large current compared to this one. Okay, so the larger resistance, the lower the current that flows through it. So now let us calculate the current for the value, the current passing through 4 ohms. Now in this case, voltage in parallel is the same. Okay, so voltage that flows through the parallel resistors is the same. So in this case, what is the total voltage? the total voltage is 6, and therefore we are going to use the voltage of 6. Applying this formula, resistor is equals to voltage divide current. In this case, what is the resistor? We are told 4 ohms is equals to, what is the voltage? The voltage 6.0, and in this case we are dividing, we are finding the current. So 4I, which is current, is equals to 6. Okay, if you divide 4, you're going to find the current is equals to, we divide 6 divide 4, the answer is 1.5, and therefore the current passing through 4 ohms is 5.5. The units for current is amps or amperes, so in this case 1.5 amps. Okay, then the next question is calculate the value of current in the battery. This time around we are calculating the value of current in the battery and not in 4 ohms, in the battery. So in this case, this is the total current. Okay, so you still apply this formula. Current is equals to voltage divide resistor is equals to voltage divide current. What is the total resistor? The total resistor here we found 3, so therefore we plug in 3 is equals to, what is the total voltage? The total voltage is 6 volts. We are finding current. Therefore, 3, if we multiply here, 3I is equals to 6. We divide by 3, and current we are going to find to be 2 ohms. Okay? Now, if you look at this, the one that is flowing through a 4 ohms is 1.5. Since we said current is shared, therefore the one that is flowing through this one, if we subtract 1.5 minus 2, it remains, here the unit please is amp, so it remains 0.5. So the one that is flowing through 6 is 0.5 amp. Okay, so that is how you find it. In the parallel with the original resistors, increase or decrease the current in the battery. Would the addition of extra resistor between A and B in the parallel with the original resistors or resistors increase or decrease the current in the battery? Okay, so the answer to this one, that the current will increase due to decrease in the total resistance. Look at this. When we put, in this case, let me say we put another resistor there, which is Z. I'll put 2 ohms. Okay, we add another resistor, we connect it in parallel, that is 2 ohms. Then if we are to find the total current, this time around we are going to use this formula. Okay, 1 over 4 plus 1 over 12 plus 1 over 2. Okay, common denominator 12. 4 into 12, 3, plus 12 into 12, 1, that is plus 6. So we are going to have, in this case, 4, that is 10 divide 12. This is just a reciprocal of each other, so in this case it will be 12 divide 10. If we are to divide 12 divide 10, we are going to find 1.2. 1.2 will be the total resistance. Now, if we are to apply in the formula to find, trying to find current, in this case, current is going to be voltage divide resistor. Okay, the voltage still remains 6, but the resistor this time around is 1.2. Now, if we are to divide 6 divide 1.2, you are going to find that this time around the current will be 5 amp. Okay, so that's why we are saying in answering this question, would the addition of extra resistor between A and B in parallel with the original resistor increase or decrease current? Therefore, we are saying it will increase the current due to decrease in total resistance. Current is inversely proportional to In this case, current is inversely proportional to resistors. As you increase resistors, current, as you decrease the resistor, current increases. Okay? So in this case, the current will increase. Here is the second question, and this question is coming from 2017 GCE. Figure 4 shows the 3 resistors connected to 12 volts battery. Figure 4 shows 3 and Y. So X is here, that is point X, and point Y is there. We are calculating the effective resistance. Like I said, effective resistance, in this case, we are just looking at the total resistance in the circuit. So, how do we solve such a question? Take note that here we have one resistor that is in series. We have 2 that are in parallel. Okay? So how do we handle such a situation? So to start with, I would encourage you to work out the resistors that are in parallel first, then you add the one that is in series. So let us start by finding the resistor for those that are in parallel. So I said if there are 2, you can apply this formula where you say total resistance is equals to resistor 1 multiply resistor 2 divide resistor 1 plus resistor 2. Okay? In this case, let us make this one resistor 1 and this one resistor 2. Just for these, we are dealing with only these that are in parallel first. And therefore, we are saying resistor 1 is 12 multiplied by 6 divide resistor, that is 12 plus 6. Okay? So in this case, if you multiply 12 multiply 6, the answer is 72. Now 72 divide 18. And therefore, the answer, that is 72 divide 18. We are going to have 4. Okay? So we have 4. 4 ohms for these 2 that are in parallel, and you add the one that is in series, which is 2 ohms. Therefore, the total resistance gives us 6 ohms. So that is how you do it when you are given such a situation. The next question is that the current flowing through the battery. Find the current flowing through the battery. So the current flowing through the battery, we are just looking at the total current, and therefore to find total current we need to apply this formula. Total resistance is equals to total voltage divide total current. We are finding total current, and therefore the formula will be voltage divide total resistance. What is our total resistance? We found it to be 6. And what is our total voltage? Our total voltage in this case of the battery is 12. And therefore, applying in this formula, we are saying 12 divide 6. Okay? What do we have? Total current, we are going to find it to be 2 amps. Okay? 2 amps, the unit for current. What is the next question? The next question is that the current through 6 ohms. We are finding the current through 6 ohms. Now, look at where 6 ohms is. It's in parallel. We are finding the current through 6 ohms. Now, if we use these 6 ohms, the mistake that most make, if we use these 6 ohms, and the voltage, since we say the voltage in parallel does not change, remains the same. But if we use the 12 volt and 6 ohms, we are going to find the current of 2 amps, which is wrong because current in parallel is shared. Okay? So now, as the current in series is the same. So therefore, here the current is 2 or 2 amps. But as it is flowing, going here at a junction, it is shared between the two resistors. And I did indicate that the larger the resistor, the lower the current that flows through it. So it is these 2 amps that is shared between the 2 resistors. So it is not this resistor getting all the 2, but some of the current flow through the 12 amps. Now, how do we find it? So now we're going to start by finding the voltage at 2 amp current. So applying this formula, R is equals to V over current. We are finding the voltage at 2 ohms is equals to, so in this case, what is the voltage? The voltage is the one that we are looking for, but the current we are sure that is 2, because current in series is the same, and therefore the voltage through 2 ohms resistor is equals to 4 volts. This is the voltage for here, okay? Current 2, voltage 4 volts. Now, the voltage in series is shared, but the current is the same. So now, when this voltage passes through or flows through 2 ohms, the remaining is the one that flows through the 2 resistors. Therefore, we are going to subtract 12 minus 4, giving us the voltage that is passing through all these 2 to be 8 volts. Even here 8 volts, since voltage in parallel is the same. So now we can go on and now calculate the current through 6 ohms resistor. Applying the formula, resistance is equals to voltage over current. Okay, we are finding current, so in this case it will be current is equals to voltage divide resistor. Okay, what is the size of the resistor? 6. The voltage is 8, then the resistor is 6. Okay, and therefore the current, we are going to divide 8 divide 6, giving us 1.33 amp as our current passing through 6 ohms resistor. So the remaining current out of 2 is the one that passes through 12 ohms. So if you subtract 2, you are going to have 0.67. So here the current is 0.67 amp. Here is 1.33 amp. At the end, current total supposed to be 2 amp. So that is how you go about such a question. Okay. So here is the third question in this video. So this question comes from 2017 GCE, that is 2017 school certificate past paper. Okay, 2 heaters. That is, figure shows an electric circuit in a clothes dryer containing 2 heaters X and Y connected to 230 volts supply or power supply. So here is an electric heater containing 2 heaters, that is X and Y. What is the first question in this case? When both switches are closed, the current in X is 3.5 amp. When both switches are closed, that is when we close these switches, the current in this one is 3.5 amp. Calculate the power developed in the heater X. So we are calculating the power in this heater. So the formula that we can use to calculate power is equals to voltage multiplied by current. Okay, since these are connected in parallel, therefore the voltage that flow through these 2 heaters is the same. And what is the total voltage? The total voltage is 230 volts, and therefore we can find the power. So power is equals to, what is our voltage? 230 volts multiplied by what is our current? 3.5 amp. And if you multiply 230 multiply 3.5, you are going to find 805. Power is measured in watts, so 805 watts. The resistance of X, so the next question, that is B, the resistance of X is double that of Y. The resistance of X is double that of Y. Determine the total resistance. Okay? So, what we are saying is that the resistor of X is double. Okay? What we have already as a resistance for X is double that of Y. Okay? So, it's more like this situation. 2X plus Y. Okay? So, double that of Y. So now, calculating the total resistance, we need to know the resistance of X before we even calculate the total resistance. So how do you find the resistance of X? So resistance is equals to voltage divide current. So in this case, what is the voltage? 230 volts. Divide, what is the current? 3.5. Okay? If we were to divide 230 divide 3.5, we are going to find 65.71 ohms as the resistor of X. Okay? Now, we want to find the resistor of Y. We want to find the resistor of Y. So if X is double that of Y, then we just divide the resistance of X to find the resistance of Y. And therefore resistance of Y is equals to 32.86 okay, ohms. That is the resistance of Y. Now we want to find the total resistance. I said if you have two resistors, you use the formula R total or RT, which is R total resistance, R1 multiply R2 divide R1 plus R2. So in this case, let us make this one R1, let's make this one R2. Okay? So what is the resistance for X? The resistance for X is 65.71 multiplied by 32.86 divide 65.71 plus 32.86. Okay? So in this case, what do you find? 65.71 multiply. Here is the fourth question in this video. So figure 7 below shows a circuit diagram with Figure 7 shows a circuit diagram with a lamp connected to a 12-volt battery. So we are looking at a lamp that is connected to a 12-volt battery. And of course, the current flowing through is indicated here 0.5 amp. Calculate the charge passing through the battery in 2 minutes. Calculate the charge passing through the battery in 2 minutes. So current is defined as the flow of charge through the conductor. And so there's a charge that flows through the conductor per second. So time normally we use a second. So how do you find the charge? So the quantity of a charge in this case is calculated as quantity of charge using this formula. Quantity of charge is equals to current multiplied by time. Time is in seconds, okay? So that is how you define current, the flow of charge through the conductor, okay, per unit time. So now in this case, we want to find the charge. We are given the current in this case and the voltage. Do we have time? Yes, we have time, but we need it in seconds. It's in minutes, so we need to divide. So in this case, how many minutes, how many seconds make a minute? So we have 60 seconds making a minute. So times this 2 is equals to, it will give us 120 seconds. So the time is 120 seconds that we are going to use. Current is 0.5 multiply 120, and therefore the charge in this case is 60. What are the units for charge? Coulomb, abbreviated as C. Okay, so those are the charges for charge. The next question, how much energy is transferred by the battery? So we are looking at how much energy is transferred by the battery. So how do we calculate energy? So energy is calculated as, in this case, voltage multiplied by charge. So that is the formula that you use to calculate energy in such a situation. Voltage multiplied by charge. Okay? So what is our voltage? 12. And what is our charge? 60. If you multiply this, you are going to have 720 joule. Okay? Energy is measured in joule. So that is the answer that you needed there. The next question is calculate the resistance of the lamp. How do you calculate the resistance? So when you are given a situation such as that, calculating resistance, you just apply this formula, resistance voltage over current. In this case, what is the resistance? It's the one that we are looking for. What is the voltage? Is 12. And what is the current? 0.5. So dividing, you're going to have 24 ohms. Okay, so that is what you needed to do in this question. Okay. So here is the last question in this video. So figure 8 shows a circuit diagram connected to 12 volts battery supply, or connected to 12 volt supply. So this question is coming from 2019 GCE. Okay, so here is the diagram in this question. The first question is calculate the combined resistance of 2 and 3 ohms resistance. Calculate the combined resistance of 2 and 3 ohms resistance. So in this case, we are looking at this one and this one. And if you are to look at this one, they are in the same line with each other. And therefore, we treat them as they are in series connection. And how do you find total resistance in series? Total resistance is equals to R1 plus R2 plus R3 and so on. You can keep on, in short, you just keep on adding the resistors. Okay, so in our case, we only have 2 resistors which are in series. So R total is equals to, let us put this one to be resistor 1 and this one to be resistor 2. And therefore, we are adding 2 plus 3, which gives us 5 ohms. So the total resistance here is 5 ohms. Okay? Total resistance in circuit when the switch is closed. So when the switch is closed now here, what will be the total, when we close the switch, what will be the total resistance? So now we have these two that are in parallel, and we have one that is in series. In this case, how do you do it? So like I said in the first part, that you start by finding those that are in parallel first, then you add the one that is in series. So in this case, we are going to deal with 3 ohms resistor and 6 ohm. So let us put this one resistor 1 and this one resistor 2. So those are in parallel. So now how do we do it? So since they are 2, I said you can just simply apply this formula. R1 multiplied by R2 divide R1 plus R2. In this case, what is your R1? Let us put 3 multiplied by 6 divide 3 plus 6. 3 multiplied by 6 is 18. And in this case, this is 9. So therefore, total resistance for those two is 2 ohms. Okay? Plus the 2 ohms that is in series. So if you add the 2 ohms, we are going to have 4 ohms as the total resistance. Okay? So now what is the next question? Potential difference across 2 ohms. Potential difference across 2 ohms. So potential difference is voltage. So how do you find voltage in this case? We apply this formula, R is equals to voltage and current. So what is our resistance? Is 2. What is the voltage? So it's the one that we are looking for. But what is the current? So here we are required now to find the total current before we can even proceed to calculate the question. And how do you find the total current? We can find the total current still applying this formula, voltage and current. Total resistance, we found it to be 4. So total current in the circuit, we use total resistance, which is 4. So here 4 is equals to, what is the voltage? The voltage, total voltage is 12. Okay, we are finding current. So in this case, it's going to be 4I, which is current, is equals to 12. If you divide, in this case, you're going to find current to be 3 amp. So the current in the circuit is 3. And therefore, we are calculating the potential difference for a resistor that is in series. And current, total current, is the one that flows through the series. Therefore, we take current here to be 3. Okay? So 3. Finding the voltage, just multiplying 2 and 3, which is the 6 volt. And therefore, the voltage that flows through the 2 ohms is 6 volts. Total current flowing in the circuit when the switch is closed, like we've already calculated it. So total current, we only use total voltage. We use total voltage and the total resistor. What is our total voltage? 12. What is our total resistor? 4. Total current is 2 or 3 amps. Okay, so that is what we needed to find on